Hello, this is Mr. Wyrick. I'm here to talk to you about Lesson 8.1, the first lesson of a brand new chapter, Chapter 8, where we'll start to get into trigonometry, the study of triangles. So even though trigonometry sounds scared, like, oh, it's trig, oh, we have to do all this stuff, it's really just talking about the study of triangles and some special relationships that some different triangles have, especially right triangles. The first thing that we're going to talk about is the geometric mean. Now, when we're talking about geometric mean, we're talking about proportionality and the means and extremes. So if you remember that from last chapter, that's kind of our jumping off point for this brand new chapter. The geometric mean is the positive square root of the extremes. So where we have A and B here being the extremes, X and X would be the means. So in order to make these equal to one another, these means have to equal the extremes. So we cross multiply, a good old cross multiplication sign right here like this. X times X makes X squared, A times B makes AB, so X squared is equal to AB. And then to finish solving that, we take the square root of both sides, so we have X is equal to the square root of AB. This is not the statistical or algebraic mean that you are used to, where you just add everything up and divide by however many there are. It doesn't work that way. In the example in the book, they have the geometric mean of 5 and 45. And the algebraic or statistical mean would say you add those up, 5 and 45, you get 50. And if it's going to be 50, then we would divide that by 2 and say 25 is the mean. And if you're doing statistics, like you've handed out a survey, and you got everybody's age range, yeah, that would be the mean, that would be the average. Same way with algebra, if you have a long list of like test scores and stuff like that, and you want to find the mean, it's the average. This is way different. So 5 and 45, the geometric mean, you would take 5 times 45 and get 225, and then the square root of that would be 15. So it's very different. We have a couple of theorems. You need to make sure to get this definition down. Take down an example if you need to. And then we have some theorems to look at. If an altitude is drawn to the hypotenuse of a right triangle, it is similar to the original right triangle, and the two triangles that it's been cut into are similar to one another. So if we imagine this large triangle as triangle A is similar to this larger triangle here, which would be triangle, we can call that triangle B, and they would also be similar to, in a smaller proportion, triangle C. So if we have that altitude, we've got proportionality, we've got similarity, just like we were looking at in the last chapter. You can see why they picked this as our jumping off point. It's an easy transition from what we're doing. It's not doing something completely different. However, when we get down here to 8.2 and 8.3, on 8.2, if you draw an altitude to the hypotenuse of a right triangle, remember altitude goes from the angle and it is at 90 degrees there. If we draw an altitude to the hypotenuse, the altitude, labeled here with H, is the geometric mean of the two sides, or the two sizes that it cuts that hypotenuse into, labeled here as X and Y. So X over H is similar, or is going to be equal to H over Y, those similar triangles. Okay? It's the two legs of the triangle. Okay, so it's going to be proportional there. That altitude is the geometric mean, so we're going to end up with H squared is equal to XY. So H, the height of this altitude, the length of that altitude, is going to be equal to the square root of X times Y. Now on 8.3, there's another one, and it's a little more difficult to wrap your mind around. There's some thought involved. If, again, we have a right triangle, and we draw an altitude to the hypotenuse, the leg over here is the geometric mean between the original hypotenuse and the fractional side that it cuts the hypotenuse into. Okay, it's in between. You can see what's going on. This is the hypotenuse of my new one. This is the hypotenuse of my original. So I say that this leg is to this hypotenuse as this leg is to this hypotenuse. And it has to be the one on the side that it's been cut from. Okay, so C, the whole hypotenuse, x plus y, is to B as B is to x, the portion, or C, the whole hypotenuse, is to A as A, the leg on this side, is to y. You may need to make sure you check in the book, check the pictures, make sure you have figured out what is going on. And the problems that we will work from 8.1, I'll try to not make them quite as big because there's a lot of different stuff that's going on here. We'll say 8 through 23. And then I'll want you to do 32 through 37, and then 42. Okay, so we'll do 8 through 23, 32 through 37, and then number 42 as well. Those will be the problems that we will work on 8.1. If you have any other questions on this stuff, you need me to try to explain it again or go over it with you individually, make sure to come in to tutorial time and ask those questions. We'll see you then.